and welcome to Stream 3. My name is Christina Kadar. I'm a senior data scientist at NZZ, Neue Zürcher Zeitung, and I'm your host for today. Together with me in the studio is Georg Rus, who is a data scientist with Mobiliar. He will be monitoring the chat and pass me your questions. As Frank mentioned, we've reserved 20 minutes for each talk. The speaker has 15 minutes to present, followed by a Q&A session. In this stream, most of our speakers are remote, with a few exceptions, including our first talk. So we will start with two speakers who are with us in the studio today, namely Ilias Papadimitriou from Georg Fischer Casting Solutions and Marc S from Microsoft. Ilias deals with the topic of quality improvement through the use of deep learning methods. Marc is a technical solution professional for advanced analytics and artificial intelligence at Microsoft, and also a hopeless data aficionado. The title of their talk is Using Machine Learning to Reduce Costs and Environmental Impacts in Industrial Manufacturing. In this talk, you will hear how GF Casting Solutions, a division of the Swiss Industrial Corporation GF, and one of the leading solutions providers of lightweight components in the mobility and energy industry, is relying on data mining and machine learning to optimize production processes and maximize quality. Please welcome our speakers. The floor is yours.
Well, thank you, Christina. Welcome to our session. We are very happy to be with you, virtually at least, today. I'm delighted to be here with my colleague Ilias Papadimitriou from Georg Fischer Casting. My name is Marc S. I'm with Microsoft here in Switzerland as a data scientist, and I'll be giving you a quick introduction of the project that we will cover in our session. So we're going to kick things off and hand it over to Ilias in a minute, who will walk you through the business problem that we addressed with the use of machine learning methods. He will also mention to you the learnings that we had, the challenges that we faced. And to kick things off, we wanted to give a brief overview of the technology stack that we used for our project. So the origin of everything here is the process data that's being generated by the high-pressure die casting process. Ilias will elaborate on that in a minute. And what we did is we transported that data into the Microsoft Azure cloud, where we then used our machine learning services to mine for patterns, to bring these data together, and to finally come to the conclusions that we have come through, which we will hear in a minute. The plan to develop this further is also highlighted here, where we're going to attempt to automate certain aspects of this process with components such as Data Factory, such as Kubernetes to deploy models to basically make retraining of machine learning models more seamless and more automated. With that, Ilias, the floor is yours. Take it away.
Okay. Thank you, Marc. Hi, all of you. I'm very happy to be here today to give you some information about this project that we started last year in our company. Georg Fischer is listed on Swiss Stock Exchange. This is an industrial company, international industrial company with more of 200 years history, with headquarters in Schaffhausen and on the moment about 50,000 employers. Actually, we have three divisions: the GF piping system, the GF casting solution, the GF machining solutions, and we supply our customers with different products, and we have in our company different production types for different products. Now we concentrate, actually the project that we started last year is focused on the casting solution, and then actually in the casting solution we have a lot of different production possibilities, and we concentrate actually on the high pressure die cast, which is actually a widely used industrial process to produce thin-walled and high-precision casting components of aluminum, magnesium, or other alloys. What you see here, you see the physical model and numerical simulation for this process. The molten metal injects it through a cavity with a very high velocity, and we fill the cavity. This is the cavity represents actually the geometry of the part. Now, just think that this process, the filling process, it's about milliseconds. It's like explosion. It's very quick, and there's a lot of phenomena, non-linear phenomena that occurred in this process, and we try to simulate it using some simulation, some numerical methods. Now, saying this, we go to the next point, which describes actually our problem. And it's not specific, this is not a problem that is specific to the high pressure die cast, it's a general problem. And you can face it at different production lines. When you start a production for a product, you have on the beginning a very high scrap. The reason is that on the beginning of the production we don't know exact parameters. How can you tune? How can you operate your production? And with the time being that you learn about how you can change the production parameters in order to get the good quality. Now, a typical learning curves represents. You see here some typical learning curves that represents efficiency, and you can find these learning curves with different names like experience curves, cost curves, efficiency curves, productivity curves. Now, the target in our project is to flat these curves on the beginning of the process in order to get to reduce the scrap of the products. And we done it by another thing that I have maybe to say here, that this high pressure die cast process, it's very is controlled. That means we measure every data. We have a very high amount of data that we use it then to produce to apply in our project. This data, we can divide it into three types of data. The first of all, we have a block of data with about 80 signals that simultaneously recorded during the process. Then there's another block of data that's about 50 additional records that are not really relevant with the products, like time, like the number of the tool, or if there are some manual operations or not. And the third part is the quality data. That means on the end of the production we produce, we have the part, and we have to measure it. And on the high pressure die cast, there's some typical quality issues like distortion of the part, or porosities of the part, or a lot of different quality criteria that should be checked. And now in our case, we concentrate it in one criterion, quality criterion, and then we put all this data sets on the next step, which is data pre-processing. That means that here we have really to make a cleanup of the data, because not all of this data are necessary for training a model. And this is something that we done using the Python, which is, I think, today's standard tool for this purpose. And we run this. We put all the data on the first phase there, and we done this pre-processing. And then the next step was actually to shift the data on the Azure and Microsoft Azure cloud to run using AutoML to train the data. That has been done. In our case, it was not very For the time here, it's not very difficult because there's a table data. It took like some minutes to make the training of these models, and at the end, what we get out, we get the best model. Here, I have to say that it was very important that in Azure we have the possibility to run different algorithms in order to get the best model. That's actually the model that we need for the next step. With the next step is actually, first of all, is to check out the quality of the model. We use this, let's say, standard methodology for classification problems, like this confusion matrix. In this case, you see that we have a very good correlation or very good model quality. Now we pass into the next step, which is actually to use this model to perform some simulations, some virtual production simulations, and based on this model that we get from Azure, this here is a pickle file that we used actually, and to do it, we run some design of experiments using this Latin hypercube sampling. In our problem, we run about 5,000 simulations using this model, and then we try to find out what is the optimal input parameters, and to give some suggestion in our production. The colleagues in the production, we've done actually with this we just give them this build that sure here it's not possible to change every parameter, but the colleagues of the production they try to change the parameter in this way that we get these results. Actually, this is the main was actually the main process on the project. This is a pilot project. It's not finished yet. We're running this problem at the moment, and here are some things that was important. What we learned during this project is, first of all, it's necessary to have some Python knowledge, especially for the first part, the analytical part, which is actually about the 70% of the work. The second point is the using of AutoML in Azure. We have the possibility to get a very high quality training models without a really in-depth knowledge of IE. It's for someone who's engineer and it's not really very deep in this area. It's very important. Here I have to say that the support from Microsoft was very important, because they guide us from the beginning on the right way, because as you maybe already know, it's a lot of possibilities how to approach this kind of project. Another point is that this kind of projects, I think it's my opinion, should be built up like interdisciplinary projects between different departments, because you need know-how for IT, you need the know-how from the production and so on, and that's what we've done in this pilot project. Here in Casting Solution we have a very strong development department, and we was able to coordinate through our R&D department this project. Maybe another point that for me it was important that in using Azure AutoML, you don't have really the possibility to go in detail on the model, to see everything in detail. And now, for this project, it's not important, but maybe it's important. Maybe if you would like to do some development work on these models, maybe for the future for Microsoft, it's good to implement some kind of detailed analysis of these models for the users. Now, what's the next steps? We divide in two. We can divide it in methodology and project. First of all, from the methodology point of view, we have to extend the models, use more quality criteria. At the moment, we focus on one quality criteria. We know there is at least 3 or 4 quality criteria that we have to cover or to investigate. And we think about using GAN methodologies on reinforcement learning to do it, because we are not sure that the methodology that we have at the moment is the right one or the best one. For the project point of view, we have to evaluate these results on the production. The first information from the productions are good. That means they say that yes, these are parameters that really we know from experiments that have a very high influence on the quality. And the first step in the long term or medium term is to integrate the whole process chain and maybe to transfer the methodology in other foundries in China or the United States, because at the moment we run it project in Europe with a foundry which is based in Austria, in Altenmark. And yes, if we can succeed, have some success in this project, the plan is to implement it in all our followers. So that's all from my side, and we are open for questions.
Thank you, Ilias. Thank you, Marc. I want to encourage the audience to ask any questions they might have in the chat. We will try our best to ask them all. We have a couple of minutes now, so I already have one question. How much data was necessary to train a sufficient model?
Maybe you can take that, Ilias.
Actually, it was about 2,000 data points, let's say in this way. But I think we can do it with lower. I think with our target is now with 500 or 400, because 400 we produce about 400 parts in a batch. And I think we will be able to do it. Or I don't know what.
Yeah, I think you're right. So one observation, so to speak, is always one physical part being produced, right? So that bears costs with it. And for this specific tool that Ilias was talking about, they had about 2,000 observations, and then the number of variables that you mentioned.
And how many parts were there? Also 2,000?
Yeah, so basically that was the number of parts. Yeah, 2,000 parts.
And a further question here: how many production runs were used?
I think you had, if I remember correctly, first you had 2, and then you did a third one, right?
Yes.
Yeah. So when they produce these kind of parts, they happen, as Ilias said, in batches, right? So they have to prepare the machine, and then they would produce a couple hundred of them at once, and then produce something else. Yeah.
How long did you take to develop the prototype? Once you had the MVP, once you had the idea?
That's a good question. It's actually funny how the idea came apart. It happened when we were playing basketball in Schaffhausen together. So that was in winter. That was sometime in winter. And then we started to really work on it, I think, in January, if I'm not mistaken.
Yes.
So it's about half a year, plus minus. I would say, yeah.
And were you to run this or to deploy this productively? How much effort do you think it will need?
Good question. I mean, that's one of the things you mentioned, right? What we want to do next. I think the technical side is one aspect. How do you deploy the models? Where do you deploy them? The more important aspect, in my opinion, is going to be what you do on the process side, and how do you actually bring that into reality.
Yeah.
So that's really hard for me to estimate, and I think it's a novel thing for GX as well.
I think it's very important here to say that one of the difficulties was to convince the people on the production that there's a methodology, there's a new methodology that maybe can help us. And if you don't have this possibility, it's very difficult to implement this kind of program. In our case, it was easy because we have a foundry that's already has some sensibility what data and data acquisition. And I have to say that we have a very, very good data acquisition system in our company worldwide. And we have the same system also in the States and China and Europe. That's helped us very, very good.
I think we have 1 more minute. Okay, we actually have only 30 seconds, so thank you very much
Thank you
for being here, and hope to see you soon again.
Great, thank you very much, Katrina.
Thanks.